Good morning. Today's lecture is going to be on modern architecture. So let us look at both the origins and the manifestations of modern architecture throughout the world. This lecture will cover inventions and discoveries, less is more, form follows function, minimalism, truthfulness of form, material and expression. So on the right, what you see is actually a picture of Joseph Paxton's Crystal Palace, which marks the invention of large-scale production of glass and the use of light in interiors. So for the first time, one could see the use of extensive glass in interiors as well as exteriors, bringing in amount of natural light and making the interiors a part of the exterior. Now, all this has a genesis in the Industrial Revolution. What was this Industrial Revolution? It was a period from the 18th to the 19th century where major changes were taking place in all walks of life, such as agriculture, manufacturing, mining, transportation, technology. All these had a profound effect on the socio-economic and the cultural conditions of the times. So where did modern architecture begin? It began in the United Kingdoms, and we know that Manchester was the world's cotton enterprise. It subsequently spread throughout Europe, North America, and eventually petered into the rest of the world. In the 2 centuries that followed, we have numerous examples of how the spinning wheel by the inventor Samuel Crompton, the model of the spinning wheel, and so on and so forth, all came up to tell us about the Industrial Revolution. There were 3 leading sectors which marked the key innovation. These were textiles, steam power, and iron making. Now, earlier, cotton spinning mills were not readily available, but the spinning jenny that was made and the spinning mule that was made by the inventor Samuel Crompton and the spinning jenny, which now we just have models in Germany, they were one of the major innovations which marked the change from the handcrafted industry to a mechanized factory spinning textile mill. The invention of steam power and the discovery of iron making as an industry, where coke was finally applied to all stages of iron smelting, replacing charcoal, changed the entire scenario of the Industrial Revolution. So the 3 main leading sectors being textiles, steam power, and iron making. Now, the knowledge of innovation, how did this all spread? You know, there were workers who were trained in a technique, they might move to another factory, or there could be a study tour taken up by one of the factory owners, and this was basically the transfer of knowledge that took place. Then there was information of philosophical societies like the Lunar Society of Birmingham, a very famous society where people met and they discussed about science and often its application to manufacturing. So the discourse of transfer of technology also took place through this transfer of ideas. The whole concept of encyclopedias came up during the Industrial Revolution. Harris' lexicon technique, Abraham Rees' cyclopedia, they all contained much value about describing technology. Periodical publications came about manufacturing and technology. They became all included and they became noticed by the latest of patents. Then we come to what is the Industrial Revolution known as the rise of metal frame architecture. What do we mean by the term metal frame architecture? It means the earlier methods of construction with only bricks or with timber were now going to be made with more lasting materials such as coke being converted to steel, smelting of iron, and the development of the metal frame structure. With innovation, with technology, with the development in the Industrial Revolution, we also had changes in the way people started touring cities. So which means people needed now to cross the rivers, they needed to cross into the oceans. So they needed better technology and they needed safe as well as quick means of travel from one point to another. Since iron was becoming cheaper and was more plentiful, it also became a major structural material following the building of the most innovative iron bridge in 1778 by Abraham Darby. And here one finds that the machine manufacturing as opposed to the manufacturing by hand played a major role. The industrial age, as we understand, is basically development of bridges over canals, the development of steam engines, the development of the railroads, the development of railway tracks. All these have a common binding material which is known as steel. So the introduction of the iron frame architecture is really, or the metal frame architecture is credited to the entire concept of the Industrial Revolution. So basically we can divide the industrial age into two major parts. The iron and the steam phase, which is 1750 to 1900, and the steel and electricity phase, which is 1980 onwards. The term iron and steam phase is also the age of the iron frame architecture. During this period, cast iron framing was introduced to masonry buildings. So masonry walls were gradually relieved of their structural control, and eventually they became a cosmetic skin over an iron skeleton of columns and arches. Iron bridges, iron and glass buildings like train stations, markets, greenhouses, bridges, all these began to be constructed. 1698 saw the Savery engine, the world's first commercially useful steam engine built by Thomas Savery, also called miner's friend. Why? Because it gave us a method and a means to be able to do mining in a more safe manner, more efficient manner, and at the same time providing for the safety of the miners. Now, the transport sector is something to be considered when it comes to the Industrial Revolution, because when you start manufacturing at a faster rate, you need raw materials at a faster rate and you need to dispose of the manufactured goods at a faster rate. So the Industrial Revolution really improved UK, England, Britain's transport infrastructure with a turnpike road network, a canal and a waterway network, and a railway network. So the three things: the land transport, the surface transport by railways, which were large wagons that could carry goods across the country, and the waterways. So all methods of transport were improved and explored. The coastal sail, the canals, the roads and the railways marked a revolution brought in by the industrial era. So we have canals coming up. Of course, we know that the Romans built the first aqueducts to carry water because they wanted to keep the water sources safe and therefore they were elevated. But at the same time, the canals now had bridges which were now going to carry even railways across them. So all the rivers became navigable, but some of them which were not really navigable had to be crossed over by these bridges. So somewhere we have the bridge over the Severn, a picture I showed you earlier, the bridge over the Thames and the bridge over the Trent. Then came the canals. They allowed bulk materials to be easily transported through the country. A national network of canals existed in Britain, and it served as a method to later construct the railways. And the last but not the least was the road network. This helped both transportation of mail and news. So both the postal services and the news services were greatly enhanced by the discovery of the canals, the roads and the railways. On the right bottom you see a picture of the Puffing Billy, an early railway steam locomotive constructed 1813-14 for colliery work. Now let's look at the rise of the metal frame architecture. I've divided this slide into 5 parts, A to E. So just trying to categorize what was this metal frame architecture all about. Early modern, 1850 to 1900, which talks about the culmination of iron frame architecture like the Crystal Palace and the famous Gustav Eiffel's Eiffel Tower. And incidentally here, what you see on the bottom is the Thames Tunnel, which was underneath the river Thames, contained and opened in 1843. And for the first time here, Portland cement, which was used in the world's first underwater tunnel. So one started looking at technology even in terms of a waterproofing material to build underneath water. So technological innovation was taking place in all spheres of technology. The late modern, B, is 1900 to 1960, where one finds the Chicago School, the skyscrapers, the functionalism by Louis Sullivan, the coming up of the international style, talking about the masters such as Louis Sullivan, Walter Gropius, Mies van der Rohe, Le Corbusier, Frank Lloyd Wright, where there was a complete aesthetic freedom. Then comes the postmodern 1960 to the present, followed by intervening periods of the Art Deco and the Art Nouveau. So all these A to E will be discussed in the slides that follow. It would not be wrongly placed to discuss the social effects of the Industrial Revolution. Now, what are the social consequences of a revolution that takes place? Largely, one sees that it is a triumph of a middle class of industrialists and businessmen over a landed class of nobility and gentry. Ordinary working people find increased opportunity of employment in the new mills and factories, and these were often under strict working conditions with long hours of labor dominated by a pace set by machines. So what did the common man do? The common man was a worker. He had an 8-hour shift, so he had no recreation. Life for him was very static and often cruel. We find images of child labor, dirty living conditions, long working hours, just as prevalent as before the Industrial Revolution. And the fate of cities was actually even worse. On the right, what you see is a picture of Cottonopolis, England, the cotton hub of the world. Pictured in 1840 shows the mass of factory chimneys. So everywhere a factory with puffing smoke was coming out. And what you see on the bottom is the water-powered silk mill at Derby. So all the images were actually depicting what? They were depicting the death of the city and the Industrial Revolution. What was it causing to the city? Further social effects of the Industrial Revolution were that while at one point of time there was grime and there was unfair living conditions, there were also philanthropists, which means there were certain industrialists who were interested in the welfare of the people. And they wanted to improve the factory and living conditions of the workers because they knew in their hearts that unless the worker is not well fed, unless the worker is not healthy, unless the worker is not cared for, he is not going to be able to put in his best, and therefore the efficiency of the factory is going to come down. So we have people like Robert Owens, who built the new Lanark mills. On the bottom you see a village of unity by the ideal worker village concept of Robert Owen. And on the right you see here a picture of Saltaire City, which was basically a salt making city. And on the top you also have a section of the Lanark, which basically we are trying to see how the water mill was functioning and supplying water to all parts of the factory, and then ultimately it was discharging into the used water, the sullage was being discharged. So it's basically a concept of the water mill. Okay? So people like Robert Owens became the key thinkers of an early socialist movement, or the rise of the middle class. More pictures of the pitiable living conditions and the workers of Lancashire. What was the write-up that was given by one of the writers of the Industrial Revolution? He said, whole streets unpaved, without drains, without main sewers, are worn into deep ruts and holes in which water constantly stagnates. So there is a lot of disease, there is a lot of chance of epidemic. And they are so covered with refuse and excrement, even the excreta, the human waste, was dumped into the streets, as to be impassable from the depths of mud and intolerable stench. So in this kind of a poor living condition, how could one expect that workers are actually going to produce good results from technology? As a result of the Industrial Revolution, huge numbers of working class died due to disease. So while there was, in a way, a pull factor of the city to bring in people because they had better work opportunities, but they had very pitiable living conditions. So disease was equally spreading. Chest diseases from mines, from cholera, from polluted water, from typhoid was extremely common, as was smallpox. Accidents in factories with child and female workers were regular. And what was the consequence? There had to be an outbreak of strikes and riots by workers, which was relatively common. So worker unions also came up along with this. Let's look at the materials now of modern architecture. We talked about the age of iron and steam a little while ago. It was 1750 to 1900, and the age of steel and electricity was 1900 to the present. In the first one, where we have iron and steam, we have iron frame masonry buildings, we have iron and glass buildings, and we have iron bridges. And in the second one, the steel and electricity age, we have steel framing, reinforced concrete serving as primary structural materials for large-scale architecture. One large or major difference in the Industrial Revolution is that for the first time we had large span buildings coming up. Large span buildings means the factories were large spans, the Crystal Palace was again large span, the warehouses were large span, the storage areas were large span, everything, the scale was very large span, and this was largely possible because of the discovery of steel, iron and glass, and of course RCC, which is reinforced cement concrete, a combination of steel and concrete put in together. Now coming back here, we talked about timber a little while earlier. You know, there was a post and beam construction that was coming up. It was the only possible way of with mass production of steel, which had immense tensile strength. Now what do we mean by tensile strength? That you can easily, it can take a lot of tension, and it is very good in being able to be ductile, in being able to be stretchable, and it can take a lot of tension stresses. At the contrary to that, timber, stone, wood, all this is very good in compression. Even concrete is very good in compression, right? So the age of steel frame architecture really comes in forth with the development of the Industrial Revolution, and followed by that is also the invention or the rediscovery. The Romans were the first to discover the concrete, but the reinforced concrete, which is simply concrete filled in with reinforcing steel bars or rebars, whereby the RCC has a combined strength of tensile as well as compression. So the advantage of RCC over simple steel is that it's able to take care of stresses which develop both as tension as well as compression. So the iron frame architecture that we talked about, it occupies the transitional zone between traditional, that's the timber, the compressive architecture, and the modern architecture. The iron frame buildings were erected during the age of iron and steam. As noted earlier, this architecture include iron frame masonry buildings, iron glass buildings, and iron bridges. Another development during the Industrial Revolution is that people were not looking at fanciful architecture, they were looking at utilitarian structures. What do we mean by utilitarian structures? Utilitarian structures are those that are largely to do with the functional component of architecture, which means we are not really looking at the aesthetic potential of architecture. We are not looking at the beautification of architecture. We are largely looking at mass-produced materials that can be there to build quickly. Also remember that this is the period of the world wars. The First World War and the Second World War, where a lot of bombing takes place. As a result, huge cities are being devastated. So people are homeless, people are jobless, people are without a roof over their heads. So we need to quickly look at a technology that can refurbish houses, that can make for mass production, quick, easy and easy to construct, quick to construct, right? So one major responsibility of the Industrial Revolution also is bringing in modern architecture which does not rely upon just aesthetics but relies on the utility or the utilitarian aspect of things. For example, we were to build mills, we were to build factories, we were to build bridges, we were to build railway stations, we were to build aqueducts, we needed to carry water through. So in order to do all this, the utilitarian building was required. And here we needed the traditional ornamentation. No, we did not need the traditional ornamentation. We needed, basically, there was not a concern for appearance, it was a concern for the function of the building. So as the 19th century drew on, many architects began to embrace these features, which were plain industrial materials, a lack of ornamentation, as being aesthetically desirable. So the industrial era is also known as the machine age. So we have the first machine age and we have the second machine age. So here are examples of utilitarian structures. On the left top you see the Severn Bridge, which is a cast iron bridge by Derby. On the right you see a marketplace, and on the bottom you see the train station. So all these are actually utilitarian buildings of the Industrial Revolution, because the Industrial Revolution also had demands which were modern. A little bit about the Severn Bridge. It is universally recognized as a symbol of the Industrial Revolution. It is an iron bridge which stands at the heart of the Iron Bridge Gorge, and today it's a UNESCO World Heritage Site. What you see on the left is actually a painting by William Williams to promote the bridge. It was commissioned by Abraham Darby because he wanted to popularize the bridge, but it has continued till date, and today it has become a foot-over bridge. But each part of the bridge was actually built like it had to be built in timber, which really means that it was important to understand the reasons behind its construction. You know, the timber side arches, if you look at these, they actually remind you of timber frame structures, but they're actually being built out of cast iron. And in 1934, this bridge had to be closed to vehicles and scheduled as an ancient monument, but pedestrian tolls continued until 1950. That's the Severn Bridge as we see it today. It's an aerial view, and it is still used as a foot-over bridge. So you can see the arches in cast iron now, of course, but largely a timber bridge. That is there. So the various stages of construction. Actually the bridge was built on the ground and then hauled into place. So hauled into position. This was the way the bridge and the cast iron track, that was the foot over, that was made. All the large castings were made individually, and because they were made individually, they were all slightly different. The joints would all be familiar to a carpenter. So which really means that there was a transition from the timber to the cast iron development, but the joints that one sees, the mortise and tenon, the dovetail, the wedges, this was a traditional way in which iron structures were joined at that time. It was later on that you started having punches and you had nuts and bolts and you had screws for steel. Earlier, the mortise and tenon, the dovetail, the wedge, the metal, the wooden screw, the nail, the wooden nails, they were still in place. Here comes the wonderful Crystal Palace by Joseph Paxton, which was unfortunately lost in a fire. It's a great architectural feat because it marks the beginning of an iron and glass architecture age. And London's Crystal Palace was basically the main pavilion of the first World's Fair. Now they also wanted to celebrate the Industrial Revolution. The Crystal Palace was a cast iron plate glass building originally erected in Hyde Park, London, to house the Great Exhibition of 1851. When I talk about celebration, I actually mean that they wanted their innovation to be celebrated. So it was actually the development of man, it was a progress. Technology marked the progress of mankind. It was a culturally vibrant era, and that's when the great exhibitions had to be lauded. So more than 14,000 exhibitors from around the world gathered in the palace, 990,000 square feet of exhibition space to display examples of the latest technology developed in the Industrial Revolution. So what was the great exhibition all about? From all over the world, you had people who had come in with their innovations, and it was a place to see and to be seen. This is Joseph Paxton's Crystal Palace interior, an interior height of 128 feet, unimaginable at that point of time. The great exhibition was 1,851 feet long, unimaginable. And because of the recent invention of the cast plate glass method in 1848, allowed for large sheets of glass which were cheap but extremely strong. It was at the time the largest amount of glass ever seen in a building, and it astonished visitors with its clear walls, the clear ceilings, which did not require interior lights, and thus fetched it the famous name of Crystal Palace. It was actually a piece of crystal. Unfortunately, we lost the Crystal Palace. It was one of the main pavilion of the world's first technology fair. But then we had something called the Eiffel Tower. It was designed by the bridge engineer Gustave Eiffel. The fierce controversy provoked by the tower's modern aesthetic illustrates the era's lack of mainstream acceptance for plain, unornamented construction. There's a story behind the Eiffel Tower. It was meant to be destroyed after the exhibition was over, and Gustave Eiffel was promised that it would be destroyed. But because it became so popular and is an icon of not only Paris but the Industrial Revolution, it stands still today. So what you see on the left is Gustave Eiffel's picture and the 4 stages of development of this. So basically, it's a stackable building in the sense that all the nuts and bolts can be removed. Each portion of the Eiffel Tower can be dismantled, and you can go and re-erect it at another place. It is actually an important landmark because for the first time it talks about mass production and reproduction, and also talks about unornamented construction. It is an iron lattice tower located on the Champs-Élysées in Paris, named after the engineer Gustave Eiffel, whose company designed and built the tower. The early modern architecture, 1850 to 1900, talks about less is more and talks about ornamentation not being a part of the building anymore, rather the form following function. The Guarantee Building is a perfect example designed by the Adler and Sullivan firm, Louis Sullivan, built in Buffalo, New York. Sullivan's design for the building was based on his belief that form follows function. The Guarantee Building, and here more examples of form following function. Now we come to the steel frame construction, which was largely popularized by the Chicago School. The steel frame architecture emerged in Chicago among a circle of architects who flourished and called itself the Chicago School. And they were the ones who were actually responsible for the first skyscrapers of the world. A good definition of skyscraper comes in for the purposes of architectural history as a metal frame building which is at least 100 feet tall. Comparing it to Joseph Paxton's Crystal Palace, which we saw was 181 feet tall, now we have the skyscraper coming up because property values are going to grow in cities, population is going to explode, so you have no option except to go upwards. So the Home Insurance Building, 1884, again demolished by William Lee Baron Jenney, a member of the Chicago School, is usually considered the very first skyscraper. the home insurance on the left. And what you see on the right is the development of the skyscraper, the building now encased in concrete. It's a steel frame building encased in concrete for waterproofing and for fire safety. While this building of the Chicago School, composed of iron and steel, pure steel frame construction, emerged within a decade. So within the next 10 years, we find that the entire weight of the building is supported by a frame.